Welcome back to math. Today we are looking at the distance formula, which is an extension of the Pythagorean theorem that we looked at yesterday. Now you'll see on the board this is an extra credit lesson, which means the quiz that's associated with it is all completely bonus points. You can give it a try if you'd like for extra credit, but you're not required to if you don't want to. You just get a few points of extra credit for it. So today's objective is, I can correctly calculate the distance between 2 points in the coordinate plane in 2 out of 3 problems. My video is kind of covering up those emojis. So think about which emoji best represents you for calculating the distance between 2 points. So we're going to talk about the distance formula, which is right here. It's kind of a big, complicated one. It's d equals big square root sign, x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. Now that's kind of big and overwhelming, but we're going to look at how we figured that formula out. We can actually derive it just from what we've learned so far. So the first thing we're going to talk about is line segments. We talked about measuring line segments in Unit 4, so we're going to review that really quick. So here we have the length of a line segment. Remember, we did this on a number line, and we have points A and B. And we said the distance between A and B is just the value of one minus the value of the other. So we're going to say here the distance of AB equals the absolute value. Remember, distances are always positive, so we need to take the absolute value. And we're going to take one of the point values minus the other point value. In this case, 6 minus negative 4. Now when we subtract a negative, we'll get at a positive, and the distance here is 10. Notice if we count, we'll get the same number. So if we start here, we count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It gives us the same value as our little formula here. So value of one point minus the value of the other point gives us the distance between the two. So if we're looking at a horizontal line somewhere in the coordinate plane, we can basically think of that as a number line, right? We could just move our number line up here, move it up 1 instead of having it on the x-axis, and then it looks just like a number line. And we will use that same idea to find the distance. We're going to take the value of x and this value of x, and we're going to subtract them. So in this case, AB is going to be 6 minus 1, so we took the value, the x value here, and the x value here. We'll take the absolute value of that, because it always has to be positive, and we get the distance between A and B is 5. Similarly, over here, we can think of it the same way, only we'll turn the number line 90 degrees. So now the number line's running up and down instead of left and right. But we're going to use the same exact logic. We're going to take the value of one point, the value of the other point, we're going to subtract them. So here, the distance between C and D is CD equals 2 minus negative 4. We'll take the absolute value of that. So CD equals minus a negative, subtract a negative, that's going to be add a positive. So CD equals 6. Again, if we count that, 1, 2, 3, 4, 5, 6, you'll see we get the same number. So we can generalize both of those. So instead of having a 6 and a 1 here, we can just say the x values, right? x2 from our second point minus x1. Take the absolute value of that. So that's just the exact same formula we've already been working with. We just put x's in there. For a vertical distance or a vertical line segment length, we're going to use the y values, so y2 minus y1. x2 minus x1 for horizontal values, or horizontal distances, and then y2 minus y1 for vertical distances. And once again, we always put those in absolute values because, why? Because distances are always positive. Okay, so we know how to find the distance between 2 points that are horizontal, 2 points that are vertical. What about a diagonal line, though? How do we measure this? What do you think? We get out our rulers and kind of, I think it's about 4 3/4 inches. How do we measure a diagonal line? Maybe we've been learning about the Pythagorean theorem. Maybe something there could help us. Maybe. So we can actually create a right triangle from the distance between any 2 points. We can just turn that diagonal line into a hypotenuse. And then if we draw a vertical line and a horizontal line that will meet, we've created a right triangle. That's because on this grid, on the coordinate plane, that grid is always making 90-degree angles, right? Every single one of these little squares makes a 90-degree angle. So no matter where this vertical and horizontal line intersect, they will always meet at 90 degrees. Well, now, can we determine the length of side A? We just looked at that, right? So this was just the x value minus the other x value, 6 minus 2. So A equals the absolute value of 6 minus 2, which is 4. Similarly for B, we have the y value and the y value, and we get B equals, let's see, that top one is 4, the bottom one is 1, and we get the length of B is 3. So A here is 4, B is 3. Now can we figure out what C is? Well, yeah, of course we can, because this is just the Pythagorean theorem now, right? We have 2 legs. We can figure out the hypotenuse, right? Our theorem is a squared plus b squared equals c squared. So we plug in those values. 4 squared plus 3 squared equals c squared. 16 is 4 squared. 3 squared is 9. And we add those together, we get 25 equals c squared. We're going to root both sides. Remember, we take the square root as the opposite operation of a square. So to get rid of the square, we take the square root. And you can either know this in your head or put it in your calculator. The square root of 25 is 5. So 5 is the length of C here. We just calculated the distance between those 2 points using the Pythagorean theorem. Isn't that cool? All right, so what if we take that same triangle now and we sort of generalize it? So now we don't have specific points, we just have x1, y1, generic wherever it is in the coordinate plane, and x2, y2. And we want to know what the distance between them is. So the first thing we're going to do is we're going to create a right triangle, which we know we can do. And we're going to list things we know so far. We made that horizontal distance formula. We also made a vertical distance formula. And we did use them, so let's list them here. We remember that the length of A is going to be this x value minus this x value. Notice that's the same as that x2 right there. These have the same x value. So the length of A is just going to be x2 minus x1. Similarly, B is going to be y2 minus y1. That's how we get the length of B, or the distance between these 2 points. So we also knew that we used the Pythagorean theorem, and we are looking for the side C. So let's solve for the side C. How about that? So we have a squared plus b squared equals c squared. If we solve for c, we just need to take the square root of both sides. So that square will go away, and we get square root of a squared plus b squared equals c. Easy enough, we just had one step to do there. So we'll list that under things we now know. The length of the hypotenuse in terms of the legs is the root of a squared plus b squared. So now this is starting to look a little bit like that distance formula. It just gets a little bit more complicated, I think. We're going to substitute in the values for a and b. So let's take that length of the hypotenuse we figured out. A squared plus b squared. And now I'm going to draw a big long square root, and I'm going to substitute in those values. So up here I have a equals x2 minus x1. I'm going to put that in for a. x2 minus x1, absolute value of all that, and all of that squared because I substituted in for a. Similarly for b, we're going to have absolute value of y2 minus y1 in parentheses squared. But that's not quite what the distance formula was, right? Not quite. It was a little bit different. It didn't have absolute values in it. Well, let's think about why that might be. So what happens when we square a number, at least a real number? If we square a positive number, so 1 squared is 1, 2 squared is 4, 3 squared is 9, we get a positive number, right? Because a positive times a positive is always a positive. If we square a negative number, let's see, negative 1 squared is positive 1, negative 2 squared is positive 4, negative 3 squared is positive 9. If we square a negative number, we still get a positive number, right? So it doesn't actually matter if this value is positive or negative because that square is always going to get rid of the negative. So basically what that square has done is it has eliminated the need for this absolute value. We can just drop it. So finally, overall, we get x2 minus x1 squared plus y2 minus y1 squared. And guess what? It's the distance formula. We did it. We derived the whole distance formula just based on the length of a horizontal and vertical line and our Pythagorean theorem. Ta-da! Sweet. So now that we have that derived, we're going to use it. We're just going to use that formula to calculate the distance between 2 points. And it says you will want your calculator for this. Why? Because we're doing square roots, and those are not terribly easy to do in our head a lot of the time. So let's do an example here. What is the distance between points 2, 4 and 7, 16? Okay, so I'm going to write my distance formula. And if it helps, you can even write the variables right below these. x1, y1. And this is x2, y2. Actually, I'm going to get rid of those parentheses and commas. You don't need those. So x1, y1, and x2, y2. So now I'm going to write my distance formula. Big ol' square root sign. x2 minus x1, so that's going to be 7 minus 2 in parentheses. 7 minus 2 squared plus y2 minus y1. That's going to be 16 minus 4 in parentheses squared. So then d equals, if we perform these subtractions, we get, let's see, that's 5 squared plus 16 minus 4 is 12 squared. We continue to simplify. 5 squared is 25. 12 squared is 144. We perform that addition. Let's see, 25 plus 144, that sounds like 169. And we can either know that one in our head or put it in our calculator. The square root of 169 is actually perfectly 13. So that is the distance between those 2 points, exactly 13. Let's try another one. Work through this one with me. What is the distance between points 1, 6 and 16, negative 2? All right, I'm going to label these again. x1, y1, x2, y2. And I just plug everything into my distance formula. Mostly it's just being careful that we get all the right numbers, right? So x2 minus x1, that's going to be 16 minus 1 in parentheses squared, plus y2 minus y1, that's negative 2 minus 6 in parentheses squared. So we perform those subtractions. 16 minus 1 is 15 squared. Negative 2 minus 6 is a negative 8 squared. Now don't worry, that's okay that that's negative because we're going to square it anyway, right? So it's going to come out positive regardless. So let's keep going here. 15 squared, I don't have that one memorized. I have to do that in my calculator. 15 squared is 225. Plus 8 squared is 64. 225 plus 64 is 289. And what is the square root of 289? Put that in our calculator. I get exactly 17. Nice. So this one came out evenly as well. D equals 17. All right, I have one for you to do now. Go ahead and give this one a try. Pause the video, and then come back and check and see if you get the same answer I do. What is the distance between points 2, 5 and negative 2, 8? So we can, we can write, oh goodness, stop doing that. I need my pen. Okay, so this is x1, this is y1, this is x2, and this is y2. Our distance formula says x2 minus x1, so that's negative 2 minus 2, squared, plus y2 minus y1, that's going to be 8 minus 5. That quantity squared. We perform those subtractions. We get negative 2 minus 2 is negative 4 squared, plus 8 minus 3 is, 8 minus 5 is 3. So then that's 3 squared. We perform the squares. We get root of 16 plus 9, which is the root of 25, and overall that is 5. Ta-da! Hopefully you got that same answer I did. If not, That's cool. Go back and see how we did it differently. Let's compare our steps side by side and see where we differed. All right, we've got a few more to try out here. What is the distance between points 319 and 312? Okay, well, we have x1, y1, x2, y2. We're going to get distance equals x2 minus x1 is 3 minus 3 squared, plus y2 minus y1, that's going to be 12 minus 19. 12 minus 19, that quantity squared. We perform those subtractions. We get 3 minus 3 is 0, 0 squared, plus 12 minus 19 is negative 7, so plus negative 7 squared. So that 0 just goes away, right? There's no value there for 0, so 0 squared is just 0. And we get d equals the square root of... Now, I'm actually not going to perform the square quite yet, and I'll show you why. Well, it's fine, actually. We can perform it. Square root of 49 is just 7. We know that's a perfect square because we just squared it, right? We just squared negative 7 to get 49. So to square root it, we're going to go back to 7. But wait. These have the same x values. What does that look like in the coordinate plane, right? If we have, well, that wasn't a very good line. If we have our coordinate plane here, and we have a value that's 319, so it's going to be 3 and then way up here, and then 312, something like that. That's a vertical line, right? We already talked about how to do a vertical line. If we just recognize that, remember we say 19 minus 12. 19 minus 12 is 7. But it's great to know that if we do the whole Pythagorean theorem, the whole distance formula, that we get the same answer. Because basically, what the distance formula resolves to, if one of these goes to 0, right? Oh, you can't see that. If this goes to 0, then all we have left is y2 minus y1 squared square rooted. So we're back to that same absolute value formula we had before. What? So cool. Okay, give this one a shot. Try it on your own, pause the video, come back and see if we get the same answer. I'm going to label these. Oh, why would I label that 2? x1, y1, and x2, y2. Okay, but, oh, I learned my lesson, right? We just looked at something like this. This has the same y values. If I draw coordinate axes, this is 8, 2, which is maybe right about here, and then 14, 2. I guess I drew them wrong, but that would be a little bit further out here, 14, 2, something like that. Oh, hi, Kitty. Kitty says hello. This is a horizontal line. So we don't need to do the whole distance formula here. Remember, we can just take the absolute value of one minus the other. So I can say the distance here is the absolute value of 14 minus 8, which is 6. Now, if we want to prove it to ourselves that we will get the same value if we do the distance formula, we can do that. This is 14 minus 8 squared, x2 minus x1 squared, plus y2 minus y1 squared, which is 2 minus 2 squared. That, we know, goes to 0, so this whole term goes away, and we get d equals square root of 6 squared. Square roots will cancel with the square, and we just get d equals 6. Same answer. Awesome. Okay, let's have you try one. Kitty, I know. It's not important right now, bud. Let's find the distance between the origin and the point 3, 5. How would we do that? Well, that's not too bad. The origin is just 0, 0, right? So find the distance between point 0, 0 and 3, 5. Round to do 2 decimal places. That probably tells us it's not going to be an integer this time. Okay, so pause the video, give it a try, and we'll take a look. This is x1, y1, x2, y2. We're going to use the distance formula of x2 minus x1, so that's 3 minus 0 squared, plus y2 minus y1, 5 minus 0 squared. So 3 minus 0 is just 3 squared, plus 5 minus 0 is just 5, 5 squared. So this is going to be the root of 9 plus 25 equals the root of 34. And I'm going to put that in my calculator because I have no idea what that is in my head. Root of 34 I get as 5.83095, blah, blah, blah. If I round that to 2 decimal places, I get 5.83. So D equals 5.83 rounded to 2 decimal places. All right, we've got one more example here. This one's more complicated, and it doesn't quite look like a distance formula problem at first. Let me move my video a little bit here. So this one asks, actually, you can put it up here, huh? Is this triangle equilateral, isosceles, or scalene? Okay, so now I have to think back to definitions of triangles. What does that even mean? Let's see, equilateral meant all 3 sides were the same length. Isosceles meant 2 sides were the same length and one was different. And scalene meant that all 3 were different lengths. So basically we need to know what the lengths of these sides are to know the answer to this question. So I guess we'll have to do the distance formula 3 times here to see if any of these sides are the same length. All right, so we're going to do this 3 times. So let's look at AB first. The distance between A and B. Well, actually, let me write out these points first so we can write x1, y1 on them, shall we? So A, let's see down here, that's 0, 1. B is -1, 4. And C is 3, 2. Okay. So now we need to calculate the distance between each of these together. So the distance between A and B, distance between A and C, distance between B and C. I'm going to use some different colors to do this so we know which one we're looking at. So let's use orange first. So A to B, that's what we'll do first, the distance from A to B. So this will be x1 and y1. This will be x2 and y2. So the distance from A to B is going to be the square root of x2 minus x1 is -1 minus 0, that quantity squared, plus y2 minus y1, 4 minus 1, quantity squared. Nope, and I need an equal sign in here. So AB equals, this is going to be -1 squared, plus, let's see, 4 minus 1 is 3 squared. We perform those squares, we get 1 plus 9. 1 squared is 1, 3 squared is 9. We get AB equals the square root of 10, which is approximately, let me put that in my calculator, 3 point something, 3.162. Okay, so now let's change colors here. I'm going to use purple. And we're going to look at the distance from A to C. So this line right here. Oh, I didn't draw that very well, but this line right there, A to C. Okay, so this is x1, y1 again. This will be x2, y2 in purple. The distance from A to C is going to be the root of x2 minus x1, that's 3 minus 0 squared, plus y2 minus y1 is 2 minus 1 squared. We perform those subtractions, we get 3 squared plus 1 squared. That's going to be 3 squared is 9, 1 squared is 1. Oh, and look, that looks like the square root of 10 again. Square root of 10, square root of 10. So, we know that AB and AC are the same length. We can actually mark that on here. Remember, we can do a little single tick mark. That means they are congruent. They're the same length. So we know this is not scalene because at least two of the sides are the same length. Now we have to figure out if BC is the same length. All right, so our third combination here. Maybe we'll do green. We have x1, y1, and x2, y2. I'll just draw a line and start working over here. So the distance from B to C is going to be the square root of, oh, I'm going to run out of space, huh? x2 minus x1 is 3 minus negative 1 squared. I'm just going to come down here, pretend it's to the right there, plus y2 minus y1, which is 2 minus 4 squared. So that all goes into the root. So BC is going to equal, let's see, 3 minus negative 1, that's going to be 3 plus 1. So that's the root of 4 squared, plus 2 minus 4 is negative 2 squared. We perform those square functions. We get 4 squared is 16, and 2 squared is 4, so 16 plus 4. We get BC equals the root of 20. Now, we see that that's different than the root of 10, right? We could put this in our calculator and see that it comes out as a different value. Root 20 is 4.472, approximately 4.472. Oops, that looks like a 9. But we don't even actually have to perform that calculation because we know that square root of 20 is different than the square root of 10. So this side is a different length. That tells us this is an isosceles triangle. Two sides are the same, one is different. Didn't look like a distance problem at first, but it totally was a distance formula problem. We just had to do it 3 times. So that is everything for today's lesson. Remember our objective here today. I can correctly calculate the distance between 2 points in the coordinate plane in 2 out of 3 problems. Look at those emojis. Think, which one best represents you?